All right, this is problem 12.3.25. And the problem is asking us, it says that we have the owner of a minor league baseball team pays the players and coaches bonuses, which are certain percentages of their regular salaries each time they win a game. And these are the amounts. And the question is, how many of the bonus amounts are within one standard deviation of the mean? Okay, so to answer this, what we're going to have to do is find the standard deviation of these numbers and then determine how many of them fall within one standard deviation of the mean. Okay, so the first thing we need to do is just find the mean. And so finding the mean is just doing the average. And so I'm going to go ahead and add all of these numbers up and then divide by however many of them I have. Okay, and there's 12 numbers, so we're going to go ahead and divide by 12. And when you add all of that up and divide by 12, you're going to get, I'll just write it here. I'll write it on a separate sheet. So adding those up, you're going to get 2490, and dividing by 12, and you're going to get 207.5. Okay, so that 207.5, that's our x bar, so that's our mean. And we're going to use that to calculate the standard deviation. Okay, so the standard deviation formula that we're going to be working with is not the one that's presented in the MyMathLab. This is an easier formula to work with. So it's the sum of the x squareds, square root of the sum of the x squareds minus n times the x bar squared. And this is all over n minus 1. Okay, so what we need in order to be able to use this formula is we need each of these component pieces. So we need to find the sum of the x squareds. We have our mean, and we know n is 12. Okay, so we need to do this. So we're going to do a chart, and to save you from having to watch me type all of this on my calculator, I went ahead and did it ahead of time. So it's all we're doing is squaring these numbers. So if you take 75 on your calculator and you just square it, you're going to get 5625. I don't know how well you can see my calculator there, but we're just squaring. Okay, and here's what we get for each of these numbers. So 105 squares into this, and so on. Okay, so that's just a bunch of calculator work to get to that point where we've got all of these numbers for the x squareds. And now what we want is the sum of the x squared. So we're going to take each of these numbers in this column and in this column, sum them together. And the number that you'll get when you do that is 582,400. Okay, so this number is going to go in right there. And then our n is 12. We have our mean, that's the 207. And then we know n minus 1 is going to be 11. Okay, so we're just going to go ahead now and assemble the standard deviation given all of those numbers. So the standard deviation then will be So the sum of the x squareds is that 582,400, sorry, minus the n, which is 12, and our mean, the 207.5, and we're going to need to square that. This is all over n minus 1, which is 11. Okay, so if you do 207.5 and square it, you need to do the square first, and then multiply by 12. Then you're going to get this number here is 516,675, and that's all over 11. Do the subtraction, divide by 11, and you get 5,975. And then if you take the square root, then you're going to get about 77.3 if we round it. Okay, now in this problem, they weren't asking us for the standard deviation. They were actually asking for how many of the bonuses lied within one standard deviation of the mean. So that was the question, was how many of the bonuses are within one standard deviation of the mean. Okay, so what we need to do is we need to analyze this. So the mean was 207.5 and our standard deviation is 77.3. So that means we're going to look one standard deviation above, which is adding 77.3, and one standard deviation below, which is subtracting it, and we're going to see which of those bonuses lie within that region. So I'm going to go ahead and add 77.3, and then I'm going to take 207.5 and subtract 77.3. Okay. All right, when we do that here, and I'm going to go ahead and round here, we get 285. And down here, if I round that, we get 130. So what we're looking for is how many of these numbers right here fall between these two numbers. And so if we just count, so we want to be higher than 130 and less than 285. So here's 1, 2, 3, 4, 5, 6, and it looks like 7. So 7 would actually be the answer here. That's what they're looking for. And that's it in this problem.